それでは次のセッションを始めさせていただきます。タルンイエンさん、シャーリー・クオさんによる事前収録動画の講演です。タイトルは NAS as not as secure。NAS はそれほど安全ではないです。それではタルンさん、シャーリーさん、よろしくお願いいたします。
Hello everyone, welcome to our talk. This is NAS as not as secure. I'm Ta-Lun Yen from TX1 Networks. Also, we have Shirley Kuo from Zuso Generation. First, we will go through the background of our research. Our research is regarding recent ransomware attacks against QNAP NAS devices. QNAP is a major player in the field of network-attached storage, but we have seen lots of attacks targeted against QNAP. So it can probably mean that either attack against QNAP devices are very profitable, or QNAP devices has a great amount of attack surfaces. Why this should be treated seriously? We believe NAS devices are usually filled with precious data, and they are usually not closely guarded. In most cases, they are treated as a black box, being set up by IT professionals in enterprise or by end users and run in your internet. These devices are usually close to some interesting segments, for example, inside your local network. Thus, they can be used as a foothold or relay for another attacks because it's natural for NAS devices to be set up through NDVNZ or a terminal. We're interested in a recent attack called QLocker. Something special about it. One is after our investigation into QLocker, we found our own vulnerability very quickly in the component affected by QLocker. This suggests that the affected component might still be very unsafe. The QLocker ransomware spreads quite fast and it operates differently like others. It uses a shotgun approach. It asks for a little ransom and hits a big amount of devices. Plus, we haven't looked into NAS devices before. It can be a good time to do so. We will go through what we call vulnerability archaeology. First, we are met with this QNAP's own security advisory. In this advisory, it states the version number affected by QLocker ransomware. And also, from this advisory, we know the name of a ransomware node and how it encrypts the files. And looking further into social network, here are some claims from QNAP. This is posted on their Facebook page written in Taiwanese Mandarin. This is a rough translation. QNAP claims that it's not a hard-coded backdoor used by QLocker, and they are targeting HBS3. But to validate QNAP's claim, we must dig into their older versions. Here's a project on GitHub which allows you to extract QNAP update packages. And if you don't happen to have an old QNAP package ready, you can make one yourself. You can download it from QNAP's own CDN by changing the version number in the URL. But be aware that QNAP will remove older versions or old vulnerable versions, so you have to make backups very often. Then we can try to tell what is fixed by QNAP. First, we can see what's stated in their change note is 1. They have fixed a credential vulnerability. 2. They fixed 2 command injection vulnerabilities. So we can try to tell the direction we need to look in by looking at the patch notes. Once we have extracted the package, we can use diff on 2 versions. And because the HBS3 is written in Python, it is trivial to do a diff on. So we came up with some very interesting findings. By searching through tags, we found mentions of a backdoor SID. SID is roughly an access token in QNAP's language. This is quite weird because this contradicts with QNAP's claim. about no backdoors, but we're seeing something related to using backdoor SID. And also inside the update script, it mentions about removing the entire CGI path. So it must mean that something very wrong is going up with the CGI. We did investigate further into this, but it's better for Shirley to elaborate. The lists are exploited by QLocker. And QNAP has made some mitigation inside a component called malware remover. According to Bleeping Computer, they have changed 7-zip to some script which will log the execution command line to some log files and backlist some Python files via file name. So maybe QNAP is assuming everyone using 7-zip is QLocker. So at this point, without any public disclosure and write-ups, we know 1. QLocker is using something related to what is removed. 2. QLocker uses 7-zip to do something very bad, such as encrypting your files. So we came up with a Yara rule. We found our second stage payload. We found the URL by looking into Google for its ransom domain. We found the second stage payload. It tries to encrypt the disk by an embedded RSA public key. But we still don't know what is the exact initial vector, because the operator has stopped ransoming new devices by the time we have started the research, so we did not catch any intrusion attempts by honeypot. So we'll try to break HPS free again. So what is HPS free? HPS free is a plugin to be run on QNAP NAS. It will enable syncing between local NAS and cloud storage or remote NAS. It uses a client-server architecture. The server part is run by WSGI called RR2 server, and the client side, there's a set of scripts called RR2 client. You can feel free to play with RR2 client. It has some wonderful documentations and a very helpful command line. HPS free, so on the server side, there's a huge handler handling numerous commands, but something called RI. This instantly took our attention. Why would login and other commands implemented separately in the same layer? This seems weird, so we take a deeper look. When you're trying to run a custom plugin in an HPS free server, it will try to import the module directly and run it. Then we locate the folder of said plugins, and we found some interesting commands. However, the commands doesn't even check for any authentication. In this branch of HPS free, authentication has to implement per plugin. And in the case of this handler, it does not even check for authorization. So the server will accept and run any commands sent over internet by strangers. Now we will demo how to overtake a QNAP NAS with said vulnerability. Hello, in this demo, we'll show you our proof of what we can do on the QNAP NAS. As you can see, the NAS is running a very old version of QTS, but that doesn't matter. The problem lies within HPS free. The HPS free version we have used, well, let's go to HPS free, is 3.0.21.0412. We have reported the issue to QNAP, and they have fixed it very quickly in the next version. As for our demo, we will show you something interesting. Let's try writing something else into the file system. Let's try running our POC. Well, seems like we have succeeded in running the POC. Let's go back to the NAS and check. Our POC has succeeded in creating a file in a temp directory, but we think it's not enough to alert the owner of these vulnerable devices, so we decided to add more noise into our POC. Well, let's go to our front page of the NAS. As you can see, anyone visiting this NAS will instantly be rickrolled. Thank you. So, back from our demo, we have some conclusion. There's some device fragmentation problem on the QNAP side. For example, on HBS3, there are two code branches. One is 3.x, one is 16.x and 17.x. For 3.x is used by QTS 4.3, which is an older version but still maintained version of the QTS. And for 16 and older and newer is being used by QTS 4.5, which is a mainstream version by now. They are both supported by QNAP, and the architecture on 3 and 16 are quite different. In 16, authorization is checked like a middleware, and in 3, authorization is checked per plugin. Thus, our vulnerability only exists in 3 branch of the plugin. Now, we will hand off to Shirley. She'll tell stories on how broken HBS3 and QNAP is.
Thanks for thorough introduction. Mine is Shirley, and I'm very happy to present our work at Kobu. In this presentation, I want to explain why we started the security of QSAN NAS products and what we found. But first, let me introduce myself. My company is called Zuso. Zuso is an information security company in Taiwan. We conduct penetration testing and rating assessment. While conducting rating assessment service for a customer, we found that the customer was using the QNAP NAS system. For this reason, we started investigating NAS devices, and then we found QNAP and the QSAN CVEs. In the next of this presentation, I will explain how we could find these two high security vulnerabilities. First, I want to talk about the past Traversal vulnerability. QNAP's NAS services run their own operation system named QTS. This vulnerability can modify any file and impact the system integrity in some QTS versions. The CVSS score is 8.8. That means it is a high security risk. When we started doing this research, we did not have any real NAS device. However, we found out there is a live version online that can be used for free. This service gives you access to all the QNAP NAS services, and it also includes the test applications. I think this platform is for the people who they want to try out QNAP products before buying them. When you launch this online service, you will get a demo link, an account, and a password. This platform has a time limit of 2 hours, but it's not important since we could launch another service after each time out. Okay, and this link shows the main page. From this interface, we could add new accounts, and we also could check the control panel and set up all the available services such as FTP, SSH. We decided to use the SSH service because it can be easily used to get all the detail of the system using a terminal. We connected to the live demo service, and we got an admin account login. Using this terminal, we could quickly read system configurations and reverse engineering running programs. But unfortunately, right now, you cannot use this SSH service anymore because QNAP released patched and limited some high privilege actions on the live demo platform. But I will still describe how it worked and to explain the process we used to find the vulnerability. At first, we spent a lot of time to check every application's functionality and their package. And then we found an interesting application. In the slide picture, you can see a text editor application. It can read and or edit a text file uploaded by the user to the NAS. Of course, if you upload a file using the low permission account, the file will be saved in their own folder. It is not possible to change permissions if you are a lower permission user. Then we uploaded a file and used man in the middle to intercept the package. You can see our captured package in a slide. The editor uses a special CGI command when a file is uploaded. Let me introduce the parameters used by this CGI command. You could see the parameter named SRD. It is like the PHP session token. It allows the service to identify user roles. We don't know the reason why they send the SRD 3 times in the send request, but we found that the SRD has always the same length, whether the account permissions are high or low. Okay, the next parameter is file content. It contains the content of the text file, including in base64. It's worth mentioning that the upload file type is not limited to text. We could also upload other file types such as PHP. The next parameter is file name. Just like this name, when you upload a file, the file saved the user's own folder. Do you remember what I said before? If you upload the file with admin account, the file will be located in the user admin folder using administration permissions. You cannot change the permission if you are a low permission user. It is worth checking if we could add a / in front of the file name. And let me check the result. Look, we successfully upload a file in the system folder. After this experience, we are sure this upload CGI is affected by a past Traversal vulnerability. But what about a real NAS service? So we decided to buy a real NAS device and check if this vulnerability was present in it. As soon as we got the real device, we are all excited to set it up and repeat our POC attack. But unfortunately, we could not find the text editor application since it is not available by default in a real NAS device. This could mean that past Traversal could not be launched against a real server. Is it only available in the live demo version? We still could install the text editor in the NAS, but it's not a good situation for hackers because it requires the user to install the application manually. Even though we could not find the Notepad application installed by default, some team members still want to try the CGI payload. Okay, some interesting thing happened. Even though the application is not installed, the CGI endpoint still works. So we thought maybe QNAP NAS enables all the CGI endpoints, even if the application is not installed. We also try to upload the file using past Traversal vulnerability and using a low permission account user. It still works. As I said previously, we can upload any file type including PHP. By exporting this, we could execute many high privilege commands in the end. By the way, I also want to say something about a special feature implemented by the CGI script. Sometimes people like to override the system config files instead of upload a file in a new location or just upload a new file. But in this case, we cannot directly override the file via the upload functionality. About this, I want to show another interesting parameter. If you try to overwrite a file, the response will show you something wrong. To overwrite a file, we need to know the last M time of the file we want to overwrite and specify this time in the request content. But how could we know the correct M time number? The upload functionality responds with such a value, but it only does this the first time a file is uploaded. For this reason, if you want to override the system file, it is unlikely to get the file M time. So we tried many different things and finally found a way to bypass this issue. We just need to edit the M time to 0. If we set the M time to 0, we can overwrite any files without knowing its original M time. Don't ask me what's the reason of this. I honestly don't have any idea. Okay, let's summarize what we found about this vulnerability. First, the Apache service is launched by high permissions. Otherwise, the path traversal would not be able to write files in other locations. Second, we can bypass the check on the M time by setting it to 0. Okay, let's now talk about the second QNAP vulnerability. This vulnerability is well known since it is used by the QLocker ransomware, and QNAP published an article about the fact that QLocker was using this vulnerability to encrypt the victim's files. And this vulnerability allows remote attackers to log into a device. The CVSS score is 10, is the highest possible value. If you followed the event about QLocker, you may already know this backdoor, which is due to the magic password you can see on the slide. And you could also find out it's an ID that means Shirley Kuo HBS management from the article on the website. But I will not discuss the detail of this vulnerability today. What I want to discuss today is the process we followed to find this vulnerability. Maybe it could help someone else in finding the zero-day bugs in the other products. Okay, in this case, since we have the real NAS device, we can read all of its code easily if they didn't encode it and or obfuscate it. The first time you use the NAS, the system will ask you to log in using a username and a password. Also, we did man in the middle to intercept the network packets. In this slide, you can see that we found the request paraments. The paraments are used to access a CGI program named Overtaking. Maybe we could check if this CGI program has any vulnerability. So we try to read the source code, but also login CGI is compiled. Our team members are lazy and they did not reverse it in that moment. So try to do in other ways. Yes, we asked Mr. Google. We checked has anyone ever done research about this CGI program, and we actually found someone that studied in the past. So we decided give up analyzing more this CGI because we thought that other researchers had already found all the vulnerabilities about this. So we thought it will be done effective if we check another CGI. So we stopped analyze the also login CGI. We try to check every CGI file in the CGI-bin path, looking for vulnerabilities. In this step, we spent a lot of time in reviewing code. Finally, we found an interesting CGI in a folder called backup. Inside the backup folder, there was a CGI file named HBS management.cgi. This file links to other scripts in other share folder. So we started checking this script very carefully. And let's start the code review. This slide shows the main function of this script, which is written in Python. So we didn't need to reverse it. The script checks CGI parameter. We continued our analysis by analyzing the code of the function of run module. And then we triggered the run module, and we found out that the script wants to verify the user's SID and what does the user want to do in next function. So we continued tracing this function. After following the script process, we found some code that script executed when the CGI command is executed. First, it receives a package from a post request. Second, it checks whether the content type is JSON. Finally, there is a function called checkSID, checking the user SID from the post parameters. Okay. By the way, we appreciated that the command in the code were very, very clear. It also helped us to understand how every function is executed. So we checked the checkSID function, and we found that it has a special fixed SID. And this SID is that SID we saw the article at first. Even though we got the magic SID, we still need to get more information about the parameters. We want to send the payload to this CGI page. So we need to understand every element we need to send. First of all, we figure out that we need to set more environmental setting, like the HTTP map and the content type. Then we focus on the post parameter we need to set. In this picture, you can see that this parameter includes act and the SID. But there is still another parameter. The process of tracing source code is a little bit long time. Finally, we found the last one parameter, and we also found out what could it be. What could it be? Okay, let me listing all parameters we need to use in the payload. We got the magic SID and the act and the last one parameter. Okay, let's do it. This picture shows everything we found from the source code, and the response shows the result we got from the server. Until now, this is the process we used to find the backdoor. And I would like to add some extra information about QLocker. Our team was also focused on analyzing QLocker situation while it was happening. We did some research about this ransomware and computed statistics about the used Bitcoin wallet. We found that in total, QLocker got 8.4 Bitcoin until now. Okay, this is the last slide about the QNAP vulnerability. Let's move to the next topic. Actually, in studying NAS security issues, our team is not only focused on QNAP. In fact, we also study other NAS companies like Synology and QSAN, because we thought we should also do research about other different enterprise NAS services. In the next of this presentation, I will explain what we found in QSAN NAS. In this year, our team disclosed 13 vulnerabilities about QSAN products. Specifically, we found 14 critical vulnerabilities and 7 high security vulnerabilities. If you want to find more detail about the vulnerabilities, you could search my company, Zuso website. In this slide, I show a classification of all the QSAN vulnerabilities we found. It shows that most of vulnerabilities are command injection, directory listing, and path traversal. Of course, QNAP vulnerabilities are also part of those types. Because the time for the presentation is limited, I will just mention a few examples of interesting vulnerabilities affecting QSAN products. The first one is command injection. We found some transferred package contain parameters for which the code does not check the string very well. For this reason, we could send some special commands in it. In this example, we create a package to write a malicious web page in the website folder. Then we could get the shadow file by accessing this malicious web page. And then we found the hardcode password in QSAN devices too. This is a big issue, especially in this case. QSAN allows users to connect to the NAS server by SSH, but it only allows a limited console. However, in this picture, you can see that we type a special secret key after the debug command. By the way, we got this secret key by code review. After you type in this secret key, you can use an unlimited shell. And the last vulnerability is an improper access control. As in the previous slide, QSAN enabled the SSH service to connect to the console. In this screen, we can check every command by sending question mark to the console. But even if they show only 13 commands, you can also use other commands, as you can see in the picture on the right. You can also get an unlimited shell if you add /bin/sh. behind the SSH command. Because the time for this presentation is almost finished, it is time to start with the conclusion with Ta-Lun.
So, thanks to Shirley, we now know on what level QNAP NAS and QSAN are broken. Let's go to our result and conclusions. So, in our research, we broke HBS3 again, and we have also proven that enterprise offering is not secure either because we have found so many CVEs in QSAN. Some of them involve pre-auth code execution or cross-site scripts. We're still seeing common bad patterns, such as lack of input validation, weak or non-existing preconditions check, or cross-site stripping and unlock backdoor. We're very surprised because this is 2021. So we came up with some suggestions. For vendors, please be cautious while writing code for devices. Please think about whether your code can be abused, or is it safe and is not only safe in happy scenarios. Also for the vendors, you can try to employ third-party code reviews. For enterprise or SOHO end users, our only suggestion is to try to lock your untrusted devices down. You can put it behind a VPN, employ strict firewall rules, or even disable external internet for the devices. So, this will conclude our talk. Secure your NASes, stay safe, or to be ransomed. Thank you.
はい、タルンさん、シャーリーさん、ありがとうございました。本講演は質疑応答はなしとなります。どうもありがとうございました。